that is properly. And your statements here, any song? They're not too good. Don't play too loudly. Right. Okay, so we'll just go ahead and solve the problems that we have on the board. You can turn it down if you wish. You can just take a look at it for a few seconds because we're not going like 100% with it because we're still in a trial phases. Now, the problem that we have here, of course, you will have that in your instructional manual, and it is problem number 1 in the homework section. So we are doing all of the odd numbers from the homework section, and you will do the even numbers on your own. So the first problem that we have there, x plus 3y is equal to 7, and what's the other equation? Okay, now give me some assistance with that. X is equal to 7 minus 3y. But it is good if you can declare that you are taking that from equation. I heard somebody say 2. From equation 1. So from equation 1, we have x is equal to 7. This 3y that we have here will be eliminated by subtraction. So we have x is equal to 7 minus 3y. And that, although most teachers and textbooks, well, a lot of teachers and textbooks don't label this equation. We know that this equation is the simplest equation to generate the value of x as soon as we have found the value of y. So x is equal to 7 minus 3y. And you will put that into which equation? There's only one other equation, and that is equation 2. So here's your question. If you take from equation 1 and substitute that, so you say from equation 1, then you take this and substitute it into equation 1, what will be the result? And will it be wrong? So it will be 7 equals 7, and then when you transpose that, you get 0 equals 0. Read that?
Because I tried it at first and I realized that.
You tried it at first? Okay. So you tried it at first, and then you realize that you're just going into a circle. It is the result that you're going to get is not wrong, but it will not be useful. So we put that into equation 2. So we begin here. 2x. So 2, and what is x that we have here? 7 minus 3y. So where we see x, we put 7 minus 3y. 7 minus 3y. And then we are here now. 2y is equal to 6. One common mistake students make is that as soon as they make the substitution, they would have forgotten about the other term on the left hand side. I made that mistake sometimes. As soon as I made the substitution, I don't remember anything at all about this term that's right here. So that's a common mistake that students make. I made that mistake sometimes. So you have to make sure that you also include this negative 2y or whatever else is on the left hand side. Then that's equal to 6. And in our next step, we will, let's go, now take 10 additional steps here. We know negative 6y minus 2y. What will that give?
Negative 8y.
So that's negative 8y. And that, see? I didn't hear that. Right, so we will eliminate this 14 from this left hand side by subtraction. So don't be deceived by this negative sign that we have here. This negative sign belongs to what term? It belongs to 6y. This 14, what is the sign of this 14? It is a positive 14. So we will eliminate this positive 14 by subtraction. So we will have 6 subtract 14, and that will give us negative 8. So y will be equal to y. Negative 8 divided by negative 8. Any number divided by itself is equal to, the result will be 1. So we have 1 right there. And we will substitute that into which equation? Yes, into equation 3. If we do not have the foresight to include the equation 3 here, or to call this equation 3, then it might take us another step or two. But as long as we make use of it, then we don't even have to make the substitution. Because if you put 1 here, 3 times 1, so we'll have what? 7 minus 3. And then x will be equal to 4. Right. And that is how easy it is if we can have it, very simple. If we call this equation, equation 3, and make use of it while we are attempting to find the other unknown. So we will say y is equal to 1. We'll put it into this equation. We will not take it for granted. So we have x is equal to 7 minus 3 times. What is y? We discovered that y is equal to 1. So we have x is equal to 7 minus 3 times 1. And that will give us, we don't have to do it in just so many steps. 7 minus 3, and that is equal to 4. And we have discussed already how beneficial it can be if we ensure to write our final statement in the end. X is equal to 4 and y is equal to 1. Now, check in your instructional manual to see that this is actually the correct pair of equations that we are using. Okay, that's correct. Now, what did you say while solving that equation or that system? What was your first step? See that? That's a very good thing. Y is equal to 2x minus 1. And if you have used that successfully, I'm going to be using or taking an approach that it is quite unlikely, not impossible, but you wouldn't have taken that approach, or for the most part you don't expect a great percentage of the class to take that approach. Because my approach is going to be to substitute 2x for 2x. And which equation do you think that I'll target? Right. Why 2? Alright, right. So what I'll do is use this equation and use my transposition to ensure that this 2x turns out to be positive. And then substitute that for a positive 2x. Yes, that is exactly what I'll do. So Miss Barrett gave the correct answer. Not necessarily just correct, but the one that I would generate it. And of course, the reason that she supplied for the approach that I'm taking is actually the same reason that I have for taking that approach. So I will say then, from equation 2, 2x, let me see what you say 2x is equal to. 2x is equal to what? I'm waiting. 2x is equal to what? Right. 2x is equal to 3y minus 5. I really encourage my students to take a lot of steps in their minds. Not that it is not important to write the steps on your paper, but to develop your mental capacity for the subject. So instead of writing 10 steps just to say that 2x is equal to 3y minus 5, then you adapt the way of thinking to make that into one step. So we'll make that into one step. We eliminate the negative 2x from this side. That's how we do it. So we'll get 3y, and of course we'll eliminate the 5 from this side by subtraction. So this one will be eliminated from this side by addition, and this one will be eliminated from this side in the same step by subtraction. Therefore, what we will have is 3y minus 5 on the left hand side. On the right hand side, we will have this positive 2x. So if you look at the expression, the equation in reverse, we will get 2x is equal to 3y minus 5, and that is your equation 3. That we put into which equation?
1.
Into equation 1. When we put that into equation 1, right away, as soon as we see 2x, we say 2x is equal to 3y minus 5. So when we see 2x, we will just put
3y minus 5.
right. That's a legitimate substitution. So we have put the 2x as 3y minus 5. Then we have the negative y, and that is equal to 1. So we will have 3y minus 3. Let's go back. 3y minus y, and that will give us 2y. 2y is equal to, we are going to eliminate this negative 5 from this side. Eliminating the negative 5, we will have addition on the right hand side. So we have what? 1 plus 5, and that is equal to 6. So y is equal to 3 into remember now that your equation 3 is written one-sided in favor of the other unknown. Therefore, the equation 3 is always, repeat that? What about equation 1? Sure, you can put that into equation 1. But when you put that into equation 1, you transpose the 3 to this side, then you divide by the 2. With this one now, it is already transposed in favor of x. Although we have it multiplied by 2 here, it is already in favor of x. Understand what I'm saying? Right. So all you need to do, as a matter of fact, look at this. Y is equal to 3. Put a 3 here. What do you get? 3 times 3? 9. Minus 5?
4.
And what you're going to Place 2. Divide. 4 divided by 2. That's all. So 2x is equal to 3 times 3 minus 5. So we have what? 2x is equal to 3 3s minus 5, 4. So x is equal to 2. So x is equal to 2 and y is equal to 3. And as you imagine, I will attempt to take an approach to this problem that it is unlikely that you took. Because while you have one method or one approach that works, I want you to see that there are others that will also work. And that is going to broaden your knowledge and understanding. And you will have a deeper appreciation of the subject. So, what do you think I have to say from this one? Change these to equation 1 and equation 2. So I say from, which one do you imagine? If I'm going to be different, or I'm going to take a different approach from what you took, what do you imagine that I will say from equation what? 2. Right, I will take from equation 2, and I will say what? I didn't hear that. And I will say 3y is equal to 2x minus 6. And that's your equation 3. Now, if I'm standing here, I think that I'm standing here long enough for even the delay to be on the screen. So if you look on the screen, I think that I've been standing here long enough. Do you see me right there standing? Or a part of my head is gone? Repeat that? Only the hand showing? Okay. Alright. But what about the 3?
You can see everything on the board.
Okay, you can always see everything on the board. Well, that's good. Right. But as for me, only my hand is showing now, right? Yes. Right, go like this.
Yes.
It's not bad as long as you're seeing what's on the board. So we have 3y is equal to 2x minus 6. And we are going to put that into which equation? Into 1. Where we see 3y, we put. So we'll begin right there with x. Write it so that it looks like x. X plus. Right, because your 3y that you have here, 2x minus 6. So where you see this 3y, you put 2x minus 6. And that is equal to, and you hear that? Yes. So what do you say now? 3x. So x plus 2x is 3x. Equals 18. So x is equal to 6. And we will put that into which equation? Into 3. Put that into equation 3. So we say what? 3y equals 2, right? 2 6s. So 3y is equal to 2 times 6 minus 6. So 1 6 minus 6. That's correct, which is 6. So 3y is equal to 6. So y is equal to 2. So what do we say in the end? X is equal to 6. Y is equal to 2. Right. And then, although we don't imagine that a lot of individuals will be watching, I am sure that there's at least one person who is saying concerning substituting, making this kind of a substitution where we substitute not just x for x or y for y, but if we may, we substitute 2x for 2x. We have an occurrence of 2x in this equation, although it is negative, and we have another occurrence of 2x in this equation. Therefore, we can substitute 2x for 2x. And what we have here is quite similar. We have an occurrence of 3y in this equation, and another occurrence of 3y in this equation. Although it is negative, we may still substitute 3y for 3y. And I'm almost sure that individuals are saying, well, I don't see anybody making that kind of a substitution when we are solving a pair of simultaneous equations. One, as long as it is not a mathematically illegitimate step, we may make that step. Additionally, others will say, I know some learning. I not do it. Because I know some learning, and some teacher said. So I not do it. Well, if you're interested in learning, then you will embrace many different approaches and many different methods. Because in life in general, it does not come in a one-size-fits-all. So don't be afraid to make adjustments and take many different approaches to the same or to the solution of the same problem. Anybody finish number 7? Anybody finish number 9? Very quickly, we will put those on the board. So let me have number 7. And equation 2.
And x plus 3y equals 16.
That is your equation.
16.
That is your equation. Well, let's put number 9 on it right away. Let's go. X minus y is equal to those are the problems that we have. And you know, my question to you early is, on your screen, is this clear? Because it looks a little bit small on my screen, although my screen is a jumbo screen. It's clear?
Yes.
Okay, and thank you very much. Right. Well, I guess that we are some distance into the lesson, I would say, far enough for you to tell me exactly what to do with this one. And I hope that you're going to say the same thing that I would have said. So let's go. From which one? equation 1, we can solve from equation 2. From equation 1, what? 3y is equal to 1 minus 2x. A lot of individuals like to use the substitution methods because making use of the substitution after you do your transposition, most of the work is kind of one-sided. So a lot of people do that. We find that even at the university level, students prefer calculus to algebra because algebra requires so much movement from one side to the other, and they prefer to take the approach in which they can always be looking from one side. So that's how some individuals will do it. But you have to train yourself that irrespective of what is required, you will be capable of doing it. So from equation 1, 3y is equal to 1 minus 2x. That is your equation 3, and we will put that into equation 2. Then we have what? The 5x goes plus 3y. What is 3y? 1 minus 2x. And that is equal to 16. So 5x minus 2x, that will give you 3x. This positive one that we have here will be eliminated by 16 minus 1, we get x is right away equal to, and we will put that into which equation? 3. So if we put that into equation 3, we'll get what here? X is equal to? So we have 1 minus, well, minus 10. What is 1 minus 10? Negative 9. So y will be equal to? Negative 3. When you're solving any problem at all, it is good if you make your steps so clear and logical that you can just follow them quite quickly, quite easily, quite efficiently. So as soon as we have x is equal to 5, you know that y is equal to negative 3. So we put that into equation 3. We say what? 3y is equal to 1 minus 2 times x that we have found to be? Yes, we found that to be 5. So do we say y equals or 3y equals? Alright, 3y. So 2, 5, 1 minus 10, negative 9. So y is equal to negative 3. So x is equal to 5 and y is equal to negative 3. Now, students generally make more mistakes than normal in situations where they are required to manipulate negative numbers. So when you're manipulating negative numbers, you make a lot more mistakes. I discovered that in my own work, and when we used to have this detailed report on the CXC examinations, we saw that quite often, that students make a lot of mistakes when they are required to manipulate negative numbers. When they are required to manipulate negative numbers. Now, what will you say for this system of equations? I imagine that some students will say from finished in this problem with negative numbers. No more negative numbers will appear. So if you can see that early, that will greatly simplify your work. All of you should be close to 100% efficiency in manipulating positive and negative numbers. But of course, you know that I encourage you to do what? Eliminate the negatives out of your work. And do not include unnecessary brackets. Do not include unnecessary fractions. Do not include unnecessary negative signs. Right? So those are the things that I encourage you to do, or if you prefer, to eliminate from your work. So great that you saw that again. So Ms. Barrett said that we should say y is equal to x plus 2, which is the same thing that I would do. I'm not saying that the way that you said it will not work. It will work as long as you make all of your steps in a logical. Of course, you need to make them. You have to do those steps correctly, and then you just get the same answer. But I hope that by looking at this, you will see the benefits of having the entire thing written in positives. So we have from 1, y is equal to x plus 2, and that's your equation 3. And I guarantee you that as long as you are solving this system of equations, you will never see a negative sign again. So y is equal to x plus 2. That is your equation 3. And we will substitute that into equation 2. And by so doing, we get 2x plus 3 times y. What is y? X plus 2. And that is equal to 21. Can we make that one?
2x plus 3x plus
2x plus 3x. So we are putting a 2 here. Instead of a what? 6. And I'm deliberately putting this right here because on some occasions, students need to apply the distributive law and they do it in parts. So they don't distribute the 3 to the 2. So this 3 has to be distributed to not only the x but the 2. So the correct thing to have there is what you said before, which is 6. And put the x's together, we get 5x is equal to 15. This positive 6 that we have on the left hand side will be eliminated by subtraction. 21 minus 6 is equal to 15. So right there we have x is equal to 3 into
equation 3.
into equation 3. Just put 3 here and see what y is equal to.
Y is equal to 5.
As easy as that. And that is how efficient it is making use of what we call the substitution equation, or you may call it equation 3. So we have y is equal to 3 plus 2. So y is equal to 5. X is equal to 3, while y is equal to 5. Now, we will continue, but on this occasion, I need you to close your instructional manuals. Is Adam said Jesus? Yes, is you, Adam. Is you. Right. You don't have to worry about closing the manuals on this occasion because I'm going to be the one doing the work on the board and you will assist me. on the board will be quite cumbersome. Okay, so we'll take the opportunity to say hello to Mr. Gavin Edmond of Montego Bay E-Learning. Just subscribe it to the channel. I hope that he's hearing me. Yes, Mr. Gavin Edmond has done some serious work in education in the city of Montego Bay. Just in case you do not know. Montego Bay, Jamaica. And Mr. Edmond is the principal of Montego Bay E-Learning. Let me have a show of hands of anyone inside here who does any subject at Montego Bay E-Learning. Look here, let me tell you. At least one person must show a hand. Because this is Montego Bay, and I'm talking about Montego Bay E-Learning. Yes, at least one person inside here must show a hand. There's no classroom that you can go in this city and someone does not have a connection with Montego Bay E-Learning. Because, as a matter of fact, Montego Bay E-Learning is probably the leader in alternative education in Montego Bay. And we will just say hi also to Mrs. Scott, Western Educational Center. Noel Williams, Learner Center. Anybody goes to Learner Center? Okay, right. So, repeat that please. Right, so those are the leaders in Montego Bay. Richard James is not a leader in Montego Bay education at all. I'm just the one that does the mathematics. Alright. Now, so we'll go on to the next phase of substitution. As a matter of fact, it is not going to be limited to substitution, as you will see by the time we are through with this lesson. But when we are solving a system of equation in which one of the equation is linear and the other one is leading to a quadratic equation, then substitution is what we will call the universal method. It is the one that will work 100% of the time. And if it cannot work, great chance that the system cannot be solved. Now, we'll take a look at the first one. Can anybody tell me what it is? That's not it. As a matter of fact, every student was told to close the instructional manual, so no one should be able to tell. So, let me take a hold of my instructional manual. This one is the algebra, of course. And I'm running out of space here. X plus y is equal to 7. And xy is equal to 12. X plus y is equal to 7. And xy is equal to 12. Now, when you solve any system of equations, that system can be represented graphically. That means we have a graph here and we have another graph right there. Now, this graph is what kind of a graph, if you can tell? The first one. The first one will be represented by a straight line. And the other one will be represented by a what? It is not a straight line. It is a curve. Now, we will make a brave attempt with free hand to graph the solution, if it will work. That's what we will do. should be able to look at it and tell me the answer. Anybody can? Repeat that? 3 plus 4 is equal to 7. And 3 times 4 is equal to 12. Is that good enough? Sure. Who said that is good enough? Of course. Both Adams and Fisher say that is good enough. So, alright, give us a few seconds. Okay, I must just apologize for that disruption that was caused by someone making an inquiry at the door. We'll continue. So, 4 plus 3 equals 7 and 4 times 3 is equal to 12. Now, just at a glance, that answer is, I think, quite acceptable, but we have a little bit of that, a little more to it. There's a little bit more to it, and we'll see that in a short while. So we will make use of the substitution method, which is what? Let's go. What do we say? Alright, from which equation? From equation 1, what? So y is equal to 7 minus x. And that is your equation. That is your equation 3. And we will put that into which equation? Into equation 2. When we put that into equation 2, what will be the result? First of all, we have x. What is y? 7 minus x. And that is equal to 12. We may go straight ahead and solve that equation. So we say what? 7x minus x squared is equal to 12. And not wanting to write the x squared term negative, I will accumulate all of those terms on the right hand side. Where is it looking like that? Well, is it like incorrect? Alright, let's do it. We have what? X squared. What about the 7x? Minus 7x. What about the 12? Plus 12. I have to give some space to see what is going on. So, plus 12. And of course, we have that is equal to 0 already. Is this acceptable? To have everything else on the right hand side and 0 on the left? No? I know some used to do it. That's okay. Solve it just the way that you will solve any other quadratic equation. So we have 0 is equal to, and of course your factorization, we do not have to go back to 5 weeks ago. What two numbers multiply to give 12, and when we add them, we get an 87. So we have x minus 4x equal to what? X is equal to 4 or 3. So now you realize it's not just X is 4 and Y is 3, but X is 4 or 3. And we will put that into, I didn't hear that. Put that into equation what? 3. So we put that into equation 3. Here it is, equation 3, right there. So we say y is equal to 7 minus, take one first, 4. So y is equal to 3. Or y is equal to 7 minus the other one. So y is equal to 4. But you cannot just say x is equal to 4 or 3, y is equal to 3 or 4. Because when you solve your equation, you're actually finding points with coordinates on a graph where this line intersects with what? This curve. Right, you are finding the points where the line and the curve intersect. So, when x is equal to 3, y is equal to what? And when x is equal to 4, y is equal to 3. So if you're looking at that, you have 3, 4, and you will have what? 4, 3. So those are the 2 points that you're talking about, or the curve intersecting the straight line. Now we're going to take a go at it in a rough manner, not using any instrument or anything, and see what happens. Let's go. Now you're going to give me some guidance out there. Cause these lines to be almost evenly spaced. 1, 2, 3, 4, 5, 6. This one is a little bit close. 6. And we're going to do that. So by the time these are shown on the screen, I need to know that although they are pale, they can be seen. Can they be seen? This is the reason for doing it pale. And here I think. Okay. Alright. Now we have 1, 2, 3, 4, 5, 6. And more. 1, 2, 3, 4, 5, 6. No, that's something was missing. But let's get that in. The 7th one. Let's get that in. 7th one. Should be a little bit higher. Now, let's put the curve in. X times y is equal to 12. If x is equal to 1, what is y equal to? If x is equal to 1, what is y equal to? xy is equal to 12. Right. But you know that I did not cater for that on this. So if x is equal to 2, what is y equal to? 6. Right. It will go to 2, 6. If x is equal to 3, what is y equal to?
4.
If x is equal to 4, what is y equal to?
3.
If x is equal to 6, what is y equal to? Okay. So the curve will go like that. Like that. Now as it pertains to your straight line, how many points do you need in order to graph a straight line? 2, right? And it is easy when all of the variables are on the left hand side and the numbers are on the right hand side. So we can just say, if x is equal to 0, what is y equal to? 7. If y is equal to 0, what is x equal to? 7. Okay, so it will pass 7 here also. So that straight line will go like this. Like that. And it gets there. Like that. Right. And of course, you can see that that straight line will cross the curve where? That point and this point. This point being what?
4.
Put the x's first. So we have 3, 4. And this point being 4 for the x and 3 for the y. So when you solve this pair of equations, you're actually, or any pair of simultaneous equations, you're actually finding, if you can represent them graphically, you should. Right? So there's a graphical representation for the solution of your simultaneous equations. Even the ones that you have done before. But those equations are linear equations. And because they are straight lines, they will cross how many times? How many times will two straight lines cross? 1. And that is why you get a single pair of values. But for curves, like one in this case, we have 2 places where they cross. Also, it is for you to understand that this is not the full representation of the curve. Because that curve also will have a negative part. While the straight line, that looks a little bit off in places. The curve looks like this. One part is going to be here and the other part is going to be here. But for a straight line, it is only in one part that goes like that. So this curve has 2 parts. Right. But it was not necessary to include this part. It was not necessary to include this part in my demonstration. Why? Well, it's not because if we had a particular situation in which the line would cross there, then we could have negatives and we could use this part of the curve. But the line that we're talking about, which is this line, notice that it passes here and has nothing to do with this section of the graph. So we do not have to use this section of the graph because the line will not intersect. The line will not intersect with this section of the graph. Okay? Right, so that's why we just use this part. It's not that we don't have any negative values. Because if the equation were written in another way, as it is possible for the equation to be written in another way to include this part to put on board is somewhat more sophisticated than that one. So I will need your assistance for this one more than anything else. But I am sure that at one of the most critical points, most of you will not remember your early algebra. Let's see what you make of it. I will have to ensure that it is written correctly on the board because you are not required to look inside of your instructional manual. And this one will have to be right in the corner. Number 2. X squared plus y squared minus 3x plus 2y. I hear some students acting as if they are scared already. X squared plus y squared minus 3x plus 2y is equal to 12. But the other one is even more complex than that. It is x plus y is equal to 6. So what do we say? And I'm just taking a deep breath. What do we say? Come up. From equation 2 what? X is equal to 6 minus y. And that will be your equation?
3.
Just as usual. 3. Students, it's a substitution problem. We are accustomed to making substitutions. So here we go. But because it's going to be y on the board, into will go right here. Into equation what? 1. Yes, we expect it to be y on the board. So let's go. Let's put that into equation 1. First of all, we have x squared. Then we have plus what? Y squared. What is y? See? What should we have here?
6.
So, my assistants are not working, so we have to. So let's go again. Where we have the x squared, since x is equal to 6 minus y, we have what? Right. Right. 6 minus y all squared plus y squared, we are here, minus 3 times. What is x? 6 minus y plus 2y. Let's put it 12 there. Minus 12 is equal to 0. Everything will be accumulated on the left hand side to give you a very short and spicy quadratic equation. So let's expand the brackets. What do we have? Now, see the square? Let's go. 36. I like that. Minus. Plus what? Plus y squared. Not this one. Not this one. The one that comes from inside the brackets, correct? No, it seems as if I'm leaving space here. Yes. And I'm doing so for a good purpose. A good and wise purpose. What should go here? Oh! want a nicer answer than that. Bird and Company. We need the answer that should go right. And we have it coming from those, we have that coming from those, a good suggestion coming from those ladies right there. There it is. And what about you two? Why? That's a very good answer. But it needs to be not, we need to be a little bit better than 6y. No, that's fair. I'm giving you a few more seconds. Why? That's not bad, but we need a better answer than that too. Sterling and Company. Let me have that correct answer. Of course, it's negative 12y. Don't say you see. Then you should say the answer then. Do not forget that in your perfect square, we have a middle term that is equal to what? 2 times the first times the second. Well, the students who were here when we did the perfect square, you should remember this. That for the perfect square, there's a middle term that is equal to what? 2 times the first times the second. So, right here, we should have the square of 6, which is, and we need to also have the square of negative y, which is what? Positive y. And we also need to have 2 times 6 times negative y, which will give us what? Negative 12. Let me write that properly. Negative 12y. Students, if you miss that term, you will be solving this problem until of course, then we will put this y squared is the one from the bracket, and then we have what? Talk of y squared minus, if it is minus 18 plus 3y 2y equal 0. That's very nice, man. Very wide on the board. Students, you know, it's a trinomial, so you know, in the very next step, this expression will be reduced to just a trinomial. So we have y squared plus y squared, that is 2y squared. Then we have all of those y's, negative 12 plus 3 plus 2. What's that? Alright, 3 plus 2, 5 minus 12, so negative 7y plus, it is a plus. And so this color is a plus or minus. Negative 18 minus 12. When you put those together, you get a negative 30. your two numbers multiply to give what? They multiply to give 12. And when you add them, you get -7. So they multiply to give 12. And when you add them, you get -7. What are they? Let me repeat that. It's not x, -4 what? Y. And then what is the other one? Negative also 3y plus 6 equals 0. What do you imagine? So we have 2y minus 4y. This should be 2y, is it? Speak up. What it should be? 2y squared. Alright. And then we have -4y minus 3y plus 6. Now let us go and factorize this. What's common in these two? 2y, and we have 2y into 2y. Let's say that again. 2y into 2y squared. No. We have another problem like this to solve, so let us get this one right. 2y into -4y. 2. What's common in these two? 3 is common in the other two. What will we have here? Y. Negative into positive. 3 into 6. I like to take the common factor first. What's the common factor in this case? And you hear that? Y minus 2. And the other factor will be
2y minus 3.
So in this case, y is equal to positive 2 and also 3 over 2 into where? Into equation 3. What do you imagine? You imagine that every day you attend live, it will be something that you can just overpower in a second? Alright. Show me one thing on the board that you were not taught. Show me one thing. Is it the factorization of a trinomial? Is it the perfect square? Is it substitution? Is it the solution of a quadratic equation? You are taught everything, and you need to be able to put all of those components together in solving one single problem. So when you put that into equation 3, what do you get? X is equal to what? Come. X is equal to 6 minus 2, which gives what? And the other one is x is equal to 6 minus what? So x is equal to 6 minus 3 over 2, and the 6 is rewritten with the same denominator for ease of subtraction. So the subtraction is easy if we write the whole number as a fraction with the same denominator as the fraction that we have here. So if the denominator is 2, then the numerator has to be what in order that the number will be 6? This is a simple adjustment that everyone can make. Writing 6 as what? 12 over 2. So this subtraction becomes very simple and it turns out to be what? X is equal to 9 over 2. So when X is equal to 4, Y is equal to 2. When X is equal to 9 over 2, Y is equal to 3 over 2. That's life. When I'm going to play a piece of music written on the sheet, which is like 8 pages long, I have to figure out how to get in those 8 pages in the performance. Every single note with hundreds of notes on the same page. When you are solving your mathematics problem, you have a similar take. You know all the components, you just put them nicely together and you have the solution of the problem. We are going to take a look at another one. So we have another tool. Now, take a look at this one. Tell me what to do with it. X squared minus 2y squared is equal to 1, and that's your equation 1. Your equation 2 is x plus 2y is equal to 7. That's your equation 2. So you have x squared minus 2y is equal to 1, and x plus 2y is equal to 7. Let's go very quickly. Back up. From equation 2, what? X is equal to?
7 minus 2y.
That is your equation 3 that you put into? Into equation 1. When you put that into equation 1, what do you get?
7 minus 2y squared.
Oh, brackets. 7 minus 2y all squared minus 2y squared is equal to 1. Nice. So, I am sure that you're not going to be caught with one foot on the ground when you need to expand this square bracket. So what will you write for the expansion of that square bracket? 49 minus, so say 14, but the correct answer is always, I'm not hearing. Negative? Negative 14y. Any other suggestion? How did you? No. 28. Because when you multiply the 7 by the 2, you need to multiply that by 2. 7 2s times 2. So it's actually negative 28y minus, no, it's not minus, it's going to be plus. So that's what? Right, because when you square 2y, you also need to square the 2. So you have what? 4y squared minus 1 is equal to 0. So to put that together in a nice and short trinomial that you can solve in a minute, we have what? First of all, the 4y squared. 4y squared minus 28y, 49 minus 1 by a common factor of, so 4 into y squared, 4 into 28y, 4 into 48, 4 into 0, you said that already for this one, so we can put the two factors down immediately. What are they? Two numbers multiplying to give 12. Right, so y minus 4, y minus 3. So y is equal to? 3 into, right, y is equal to 4 into 3. Put that into 3, what do we get? X is equal to 7 minus 2 times 4. 2 fours. We will have to revisit this, do we? X is equal to what? 7 minus 2y. 7 minus 8. X is equal to? Y is, sorry. And then x is equal to what?
7 minus 2 times
7 minus, so that x is equal to 7 minus 2 times what? So x is equal to? Did you hear that?
1.
Let's revisit this. X squared minus 2y squared is equal to this. X is equal to what from here? 7 minus 2y. When we substitute into this, we have this. We have no doubt that it will turn out to be this. And then these are the answers. But this problem, I will revisit this problem when you return to the next class. And we will also take a look at an additional one. So, thank you very much for the test run that we have given me information saying earlier out that we are not getting any audio. But for those who still have the devices on, are you getting any audio? I heard that. Okay, good. Very, very loud and very, very clear. And thank you all very much for the trial run. Students, you will be at the end for those who are looking on in a few seconds. And I am finished already. So we will just close this trial session. That's all there is to it for today. So those students who intend to leave immediately, you know exactly what to do.